video, we are going to see a project titled A Novel Adaptive Resource Allocation Model Based on SMDP and Reinforcement Learning Algorithm in Vehicular Cloud System. Now coming to the introduction part, the proposed adaptive resource allocation model based on SMDP and reinforcement learning algorithm presents a novel and efficient approach to tackle the resource allocation challenges in vehicular cloud systems. Its adaptability and intelligence equip the model to dynamically address resource allocation strategies, optimizing network performance and offering a more reliable and responsive vehicular communication experience. The proposed model leverages the SMDP framework to capture the stochastic and time-sensitive aspects of vehicular scenarios, enabling more accurate decision-making. By modeling resource allocation as an SMDP, the system can adaptively adjust resource allocation strategies in response to dynamic changes such as varying traffic loads and channel conditions. So our main objective for this project is to enhance resource utilization and improve network efficiency in vehicular cloud systems. By combining the SMDP framework and reinforcement learning algorithm, the model can dynamically allocate resources to address varying traffic demands and changing channel conditions. This adaptability enables the model to provide seamless connectivity and improved QoS for vehicle users, ultimately contributing to a more reliable and responsive vehicular communication experience. In conclusion, the objective of our research is to develop an adaptive resource allocation model that leverages the power of SMDP and reinforcement learning algorithm in vehicular cloud systems. The model's adaptability and intelligence equip it to handle the dynamic and uncertain nature of vehicular environments, ensuring efficient resource allocation and enhancing network performance. Now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. So hardware requirement has operating system, that is Windows only, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, we have Python IDEs, that is 3.7 version is required. Now coming to the methodology part, first we have define vehicles in simulation with states. In a simulation, vehicles are represented and defined with various states which serve as attributes or properties describing each vehicle's current conditions and characteristics. These states typically include parameters such as position, velocity, acceleration, orientation, and other relevant information. Defining vehicles with states enables the simulation to model their behavior and interactions realistically within the simulated environment, providing a foundation for further analysis and decision making. Second, calculate rewards with greedy algorithm. The greedy algorithm is used to calculate rewards for the vehicles in the simulation. Rewards are numerical values assigned to each vehicle based on their actions or performance within the simulation. The greedy algorithm optimizes rewards by favoring actions that provide the most immediate benefit without considering long-term consequences. The rewards calculation is often driven by a desire to achieve short-term gains or objectives, making it a straightforward approach for simple decision-making tasks. Third, calculate SMDP rewards with reinforcement learning algorithm. Here, SMDP stands for State Model Based Deep Rewards are calculated using a reinforcement learning algorithm. Reinforcement learning is a machine learning approach where agents learn to make decisions through trial and error in an environment. The reinforcement learning algorithm models the vehicle's behavior and interactions within the simulation, learning to assign rewards based on the observed states and actions. Unlike the greedy algorithm, SMDP rewards typically consider not immediate benefits but also long-term consequences, leading to more strategic and sophisticated decision-making. Fifth, extension reinforcement learning with software. The extension of reinforcement learning with softmax refers to the use of the softmax function to make decision in the reinforcement learning algorithm. Softmax is a mathematical function that converts a set of values into a probability distribution. In the context of reinforcement learning, the softmax function is used to select actions based on their probabilities. This extension allows the reinforcement learning algorithm to explore different actions and their probabilities, balancing exploration and exploitation to make more informed decisions. 6. Rewards comparison graph. After calculating rewards using both the greedy algorithm and the SMDP based reinforcement learning algorithm with softmax, a rewards comparison graph is generated. This graph visually presents and compares the rewards assigned to vehicles by the different methods. The comparison graph enables a side-by-side evaluation of how each algorithm's rewards impact the vehicle's behavior and performance within the simulation. It might reveal insights into the efficacy and efficiency of the different approaches, aiding in decision making and further algorithm enhancement. Now coming to the execution part. To execute the project, first we need to open the code folder. Here you can see we have two Python files, the resource allocation and the test allocation. So here we have these two Python files which are containing the Python code in it. Here resource allocation, which is containing the Python script in it, is the main file. This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on the run.bat file to execute the project. This is the graphical user interface. With this we are interacting with the program. Now click on define vehicles in simulation with state button to generate vehicles as shown over here. Here on this screen, vehicle state generated. Now click on calculate rewards with greedy algorithm button to run greedy algorithm and get the output. Here you can see we got rewards as 2, 45, 953, and now click on calculate SMDP rewards with reinforcement learning algorithm button to run SMDP algorithm for getting the output. Here you can see we got rewards as 6, 54, 116, which is higher than SMDP. Now click on extension reinforcement learning with softmax button to run extension for getting the output. Here you can see with extension algorithm we got rewards as 838590, which is a higher than proposed SMDP. Now click on rewards comparison graph button to get the graph. Here in this graph you can see x-axis represents training episodes, whereas y-axis represents rewards. Blue line represents training episodes, and here blue line represents greedy rewards, whereas orange line represents proposed SMDP algorithm, and here green line represents extension rewards. Now close this project, and coming back to the conclusion part, the main conclusion drawn from this research is that our proposed adaptive resource allocation model offers a promising solution for enhancing resource allocation in vehicular cloud systems. By combining the strengths of SMDP and reinforcement learning, the model can effectively handle the challenges of vehicular environment, providing seamless connectivity and improved QoS for vehicular users. By utilizing the SMDP framework, our model effectively captures the stochastic and time-sensitive aspects of vehicular scenarios, enabling more accurate and adaptive decision making. This capability allows the model to dynamically adjust resource allocation strategies in response to verifying traffic loads, channel conditions, and user demands, ultimately enhancing the quality of service, that is QoS, for vehicular users.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.